Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. The equation, the Clairaut's equation. The Clairaut's equation is named after the name of Alexis Claude Clairaut. Alexis Claude Clairaut is a mathematician and physicist who devised an equation, a differential equation, which is called Clairaut's equation. And the period is shown here. Further, Lagrange's equation of the form y is equal to x g of p plus f of p is called Lagrange's form. The special case is when g of p is equal to p, then this equation becomes y is equal to p of x plus f of p, and this equation is called Clairaut's equation. The solution of Clairaut's equation is obtained. Solution of such type of equation is y is equal to cx plus f of c. That is, if we replace p by c, we get the general solution of Clairaut's equation. So here in this slide we see two types of equation. The type of this equation is Lagrange's equation, and if instead of g of p we have p, that is y is equal to px plus f of p, then this is Clairaut's equation, and the general solution is simply obtained by replacing p by the constant c. Clairaut's equation, the differential equation y is equal to px plus f of p is known as Clairaut's equation or Clairaut's equation, where p is equal to dy by dx. Let this equation is named equation number 1. This equation is solvable for y or x. Differentiating this equation with respect to x, we have, let's differentiate equation 1 with respect to x. We have derivative of y with respect to x. Here we have product of two functions, so using product rule, first function derivative of second plus second derivative of first, so the result is these two terms, and derivative of fp is equal to f dash p dp over dx. Let dy by dx is equal to p, and these terms are again here. Simplifying, taking dp over dx common and transposing this p to the other side, cancelling these two terms, we get 0. Here the product of two factor is 0, so either first factor is 0 or second factor is 0. Now integrating 3, this is equation 3. Integrating 3, we get, here we get integration, here we see integration of both sides. Integral of this side is equal to this integral, and dp over dx will be cancelled. We get p is equal to c. This c is the integral of 0. Putting p is equal to c, c means an arbitrary constant in equation number 1. Equation 1 is Clairaut's equation. If we put p is equal to c in Clairaut's equation, we get the general solution of Clairaut's equation 1 given by y is equal to cx plus f of c. This is equation 2. Solution of 2 gives singular solution and is discarded method. In the Clairaut's equation, on replacing p by c, we get the solution of the equation. If we replace p by c in the Clairaut's equation, we get the general solution. For example, here we see a differential equation. Here the base is e. Writing this equation as exponential in the exponential form, writing in the exponential form, we get px minus y is equal to e power p. Simplifying, y is equal to px minus e power p. This is a differential equation of the form y is equal to px plus f of p. So this equation is Clairaut's equation. Thus the required general solution is y is equal to cx minus e power c. If we replace p by c, we get the general solution of the Clairaut's equation. Let's see another example. This is another question. Simplifying, this cos will be here, so cos inverse 3p is equal to y minus px. Simplifying, y will be equal to px. Transpose this term to the left side, we get y is equal to px plus cos inverse 3p. This is Clairaut's equation. The solution is y is equal to cx plus cos inverse 3c. Replace p by c and get the general solution. Now we take another differential equation. This is the non-linear differential equation simplifying. So here we see simplification taking these two terms yp and y, taking these two negative terms to the right side, and thus they will become positive, and the remaining terms will be here as they are. Now taking common here, dividing this equation by p plus 1, we get y is equal to xp minus ap squared divided by p plus 1. This is a differential equation of the form y is equal to xp plus f of p. So it is Clairaut's equation. For the solution, replace p by c, hence this is the general solution. Equation reducible to the Clairaut's form. Some differential equation can be converted to Clairaut's form by means of suitable substitution. For example, this is a differential equation. It becomes Clairaut's equation with substitution x square is equal to u, y square is equal to v. Sometimes we have a problem to write a differential equation in terms of Clairaut's equation. So to convert the differential equation as a Clairaut's equation, we have to use substitution. So here on the screen, if we have a differential equation of this type, then we have to use substitution x square is equal to u, y square is equal to v, and thus the equation will be converted to the Clairaut's equation. Now we come to the exercise 7.13. This is a differential equation. Writing this differential equation as this is y transpose this term to the right side, and this term will be here. Now px, simplifying px minus pa minus p square. This is a differential equation. Y is equal to px minus pa minus p square as of the type y is equal to px plus f of p. This is px and these two terms is equal to f of p. So this is Clairaut's equation. Equation 2 is a Clairaut's equation. This is equation number 2. This is a Clairaut's equation. Replacing p by a constant c and 2, we get the general solution. Replace p by c, we get y is equal to cx minus ca minus c square. So this is the general solution. Now we come to the another question. This is a differential equation writing in the exponential form. So px minus y is equal to e power p. We can write this equation as y is equal to px minus e power p. This is a Clairaut's equation, and replace p by c. If we replace p by c, so we get replace p by c, we get y is equal to cx minus e power c. This is the general solution. Now equation number 3. This is a differential equation. dy by dt is equal to p, and dx over dy is equal to 1 over p. So replacing dy by dt by p and dx by dy by 1 over p, here we get y is equal to x p plus a into 1 over p. Y is equal to px plus a divided p. This is the Clairaut's equation. The required solution is y is equal to cx plus a divided by c. Replace p by c and get the general solution. This is a differential equation. We can write y is equal to dividing both sides by p. Dividing both sides by p. So y is equal to p square divided by p is equal to p x minus m plus n divided by p. We get y p into x is equal to px, p into minus m is equal to minus pm, n over p is here. So this is a differential equation of the form y is equal to px plus f of p. This is Clairaut's equation. The general solution will be y is equal to cx plus n divided by c minus cm. Replace p by c and get the general solution. This is another question. Dividing both sides by p minus 1. Dividing both sides by p minus 1, we get y minus px is equal to p divided by p minus 1. Simplifying, So y will be equal to px. Transpose this term to the left side. This is a differential equation of the form y is equal to px plus f of p. So this is a this equation is of Clairaut's form y is equal to px plus f of p. For general solution, putting p is equal to c, we have replace p by c, we get y is equal to cx plus c divided by c minus 1, that is y minus cx is equal to c divided by c minus 1 multiplying by c minus 1. This is the general solution. This is another differential equation, sine of px cos of y minus cos of px sine of y. Transpose this term to the left side. Here we have p. Now here this expression is sine of px minus y is equal to p. Now taking this sign to the other side, px minus y is equal to this one, or y is equal to px minus sine inverse p. This is Clairaut's equation. Replace p by c and get the general solution. This is the general solution. Differential equation, transpose this term to the other side. Now dividing both sides by p, so this p will be here. Now writing this y, shift this y, transpose this y to the other side, we get y is equal to this one. This is Clairaut's form. Replace p by c, y is equal to cx plus k minus 3 divided by c. This is the general solution. Simplifying this equation, we get y minus cx minus k is equal to minus 3 divided by c. Now multiplying both sides by negative sign, so this is the general solution, or further simplifying, multiplying both sides by c, we get this is the general solution. Writing p square into x square is equal to this, p square into 4 is equal to this one, and these two terms are here. Now writing p square x square is equal to px whole square. Similarly y square here, and minus 2 px into y. This is equal to minus 2 pxy, minus 2 pxy. इसी term को write this term here, writing y square here, writing this term here. Here we see minus twice, first term into second term, and similarly writing this term here and minus 4 here. So these three terms are px minus y whole square is equal to this one. Taking 4 common, now taking square root, we get y minus px is equal to this one. 4 under root is equal to 2. Transposing px to the other side, this is Clairaut's equation. Y is equal to px plus minus f of p. Replace p by c. Thus we get the general solution. If we have differential equation of this type, then we have to suppose x square is equal to u. Taking differential, we get 2x dx is equal to du. Similarly, let y square is equal to v. Taking differential, we get 2y dy is equal to dv. Now dividing 2, this is equation 2, this is equation 1. 2 divided by 1 is equal to 2y dy divided by 2x dx is equal to dv divided by du. 2 will be cancelled. We get dy divided by dx is equal to x divided by y dv divided by du. Now replace dy by dx. Replace dy by dx by p, x over y here. Replace dv by du by another p. These two p's are different. If this is capital P, then this will be small p, or if this is small p, then we will take this as capital P. These two p's are different values. This is p and this one is another p, but both the p's are different p's. The given equation becomes, now we have to put the values. This is x square, this is y. So putting values here, for this p we will replace x square y minus x over p. This is value of p. This is the value of p in the given problem. In the given problem there was p, and for that p we have used this equation. For that p we have put this value here. Similarly, in the given differential equation we have p, and we have replaced that p by this value here. Now we have to simplify this equation. This is y, x into x equal to x square divided by y. Similarly x square p square y square, तो यहाँ पे y आएगा. Now this x square is equal to u, this y square is equal to v, this x square is equal to u, this p is again here. This is the new p. डिफरेंशियल इक्वेशन, जो डिफरेंशियल इक्वेशन हमें गिवन था, यहाँ पे जो p है ये है dy बाई dx. तो इसी p की वैल्यू dy बाई dx है और उसको हमने रिप्लेस किया अपनी वैल्यू में. इसकी इसी p और इसी p की वैल्यू क्या थी, इसकी वैल्यू यही है. उसी p को हमने इसी वैल्यू से रिप्लेस किया और यह जो p है इसका मतलब है dv बाई du. तो यहाँ पे सिंप्लीफिकेशन हो गया और सिंप्लीफिकेशन के बाद हमें ये रिज़ल्ट मिला. एक्स स्क्वायर की जगह u और वाई स्क्वायर की जगह v का यहाँ भी u है, इस तरह एक्स स्क्वायर की जगह u है. अब इसी को कुछ सिंप्लीफाई करना है, इस तरह हम लिख सकते हैं. इसी u को देख ले, cancelling this u and this u will be cancelled. We get v minus up is equal to p square. This v will be here, transpose this factor, this term to the other side. Now this is a differential equation. This differential equation is of the CLAIRAUT'S form. This is a differential equation of the CLAIRAUT'S form. This v is dependent variable, this u is independent variable. Replace p by c. This is a differential equation. We have to replace p by c for the general solution. Replace p by c, we get v is equal to cu. Replace p by c, and here we will get c square. So this is the general solution. Now replacing v by its value, v is equal to y square. This is v is equal to y square, so it is the value. Similarly replace u by its value, u is equal to x square. तो यहाँ पे x square हमने पुट किया. This is the general solution of this differential